The insects is our inspiration because we come from a maker background. I'm a designer, so the approach to do your best with what you have around you is the soul of the project. So we start looking for a good approach to create locals with a local material, and we start this journey looking for this insect way to construct. So we were really fascinated by the chance to connect additive manufacturing and the real results that can work about human needs, like food, energy, earth, house, or medical devices in general. We are designers, so we created machinery that can help us to go in that direction. In this presentation, I will focus on clay and the house printer we create. This is the first case study we do times ago, 5 years ago, more or less. So our work was in the beginning creating the machine that doesn't exist before, and now we are facing the architectural topics. So we have here the first case where you can see the process where we took directly from the ground the earth, and then we go on the mixer here. Really common in Italy, this kind of machinery there, where we put husk, raw fiber in general, clay, sand together, and then we put in the pumping system, and we that way create a wall with already prepared insulation empty space. We do create with the smaller machine as a project in scale. So we usually work in a small scale, and then we scale up till the building size. Also because it helps a lot to understand the problem we can have scaling up the project. In Gaia, we use the local raw material like soil, but you can also put inside lime or cement and aggregates. The WASP project want to put on the market structural wall in raw earth, but we have to manage with a different legal phase also here in Italy. So we are open to understand how to do it properly, because it's a new application. You can see online a lot of 3D printing in concrete, which are also a new way to construct, but we want to push the limit a bit further and work on natural materials. So what we have in this wall is a chance to create insulation, also including the system, and oh, sorry. This is the first printer we have done in the past, which yeah, it was one of the biggest in the world at that time. And now we have the Crane WASP with its optimized printer with biggest surface area for printing instead of this one. You have to imagine that there's no at that time there was no previous experience in this technology. And with this easy machine, we are creating a different setup. This machine could be can be mounted and mounted, disassembled with 3 people, and it's not heavy, so it's easy to move. Because we were thinking to go also in a place where it's not so easy to construct in a traditional way. So this could be the setup for us for the building site, where you can find the machinery, the earth taken by the place or already premixed raw earth, and all these steps that create the mixture to use with the printer. This is our first case studies in our headquarters. The name is Gaia, and it was the result of the previous building site I share you. This is internal of Gaia, where we have the structural the structure, and on this wood part, and we manually work on the layer for also show that you can cover or decorate or add something on it. We really spend a lot of time thinking about insulation or where we can use in the correct way the empty space of the wall, or what we can do for this technology. You have to imagine that we are mostly designer and engineer, not architects. So we faced in the past how to this technology can put something new or different on the market or on the research. So we put inside husk of rice for insulation, and the partner for this project was Rice House at that time. Then we go on this kind of research because we want to imagine that we can put inside something printed wood part or stairs in that case. The partner was Ayak in Barcelona. They have one of our printer, and we collaborate in this research. This could be visually the final look and feel of the project. And here during the printing, then we step on Tecla. It was one of the biggest opera made in 3D printing and the raw earths. It was really, really challenging because we pushed the limit our printers. And also there was a lot of mistakes in terms of mixed design, in my opinion, but we discover later. But yes, I think we seen a point of the research with this opera, and we will step back for sure on the dome because it's a topic for 3D printing. And there was a lot of research in the internal wall for understand better how to use at the best the technology. The partner was Mapei and Milan Ingegneria. With Mapei, we thought about put ingredient inside a low percentage of material that can help us to make stable the raw earth. That was really challenging, and Milan Ingegneria was in charge of the structural calculation. Here during the printing in our headquarters, and here the inside part, there's a lot of images online. So we as we have done in the past, we thought about like not connected like an off-grid concept. His House of Dust is an opera. Maybe it's not okay. It's not interesting for you. But this one was and still in a public space in Germany. So interesting for this kind of things. And then we go in Dubai 2 years ago, more or less, where the challenge was took on the beach to printer and work directly there and really understand how to work with other people on the building site, because it was not an experiment of WASP, but it was exactly a shop, a pop-up. So the mixture here was not earth. It was a lime-based mixture with clay, sand, and fiber inside. But it was not from the beach. It's upside down, but the interesting part is that with this instrument we can go easily in a really not easy way to reach by other printers or other way to construct. The challenge was also the weather and the sea really near to the building site. So we imagine inside this kind of approach where we on the beam on the structure we also put like products or whatever. Ooh. And this is the final look. A challenge also, the big challenge for us was this pattern on the wall. You have to imagine any layer is made different movements. So we cannot at that time made a mistake, because otherwise you can clearly see on the wall. And this is a collaboration with the IAC, the first prototype they made in Barcelona with the local soil. And here during the building site. Here we are in Milan, in Triennale. This challenge was put inside the machine. As you imagine, in an old building, you have a maximum weight to be supported, but the machine was okay. And parametrically, we printed different objects with the same machine. So the chance you have with the printers is that you can print with the same material different design. This is the final look. What we are doing now is working in Italy. This is the video of Gaia, if I have time. No. Maybe it doesn't work properly. No.
Sometimes if you right click it, it might you might be able to open it somewhere else and play it perhaps.
No, anyway, what we are doing now in Italy, we have a second company right now where we want to sells houses 3D printed in natural material. So WASP is focused on machine and research on the machine, but WASP 3D Build want to really be on the market for that purpose. And we are now working on our own buildings, Ithaca, 30 kilometers from WASP, for show and proof that this kind of application could be right now done and created also in Europe, in Italy, because they do with a cement, with concrete in 3D printing, but there's no space right now for natural material. So we are the first team of people that want to achieve this big and challenging project. So we started 10 years ago. So we are kind of a really young company, but now we have enough experience to proceed in that direction. And we also believe, thanks to our previous experience, that this is the right way to proceed for a better future. So that's it.
Thanks, Francesca.